Hi guys, I'm back with part 2 of the last video, which was about the summing amplifier. And in the last video I built this circuit with a op amp, the UA7401, with a split supply, with the non-inverting input going to the virtual ground or 0 volts, and then the inverting input going with the resistor feedback and 2 resistors attached to it that are of the same value. And when you apply 2 different voltages, V1 and V2, to these resistors over here, on the output you'll get the first voltage plus the second voltage times -1, so it inverts it. And I told you guys that you can use this circuit for audio mixers and simple addition, but you can also use them to make a simple digital to analog converter if you use different resistors. So let's just say you had, like over here, you had an R3 and an R4, and then these two were different values, and let's say this was 10K, 20K, and this one was 40K, and this one was 80K, and your R1 was 10K. You could put your binary data in here, and on the output you get a analog voltage signal, which is the simple fundamentals of a digital to analog converter. And another thing they can be used for is to add a DC offset to an AC signal or to an oscillating signal. So with the 555 timer, I was able to make this signal. It's a pretty simple signal. It just goes from 0 volts to 4.5 volts. It's a square wave. And whenever I put it to the V1 pin, this is the signal, and then on V2 I put a 1.1 volt offset, which I got from a resistor divider network. As you can see, I got something interesting. So it would go to -1.1 volts at its top peak, and then the low was -5.5 to -5.6 volts. And here, let me just write that a little clearly. I don't know why it's so ugly. So this would be about more like 1.17 about, or 1.2 volts, because the 555 timer doesn't go exactly to 0 volts. It goes to like about 0.07 volts, and then the bottom peak would go to about -5.5 to -5.6 volts. And this makes sense because if you take 1.1 volts plus 0 volts, well, 0.07 volts, you get about -1.17 volts, and if you times that by -1, you'll get -1.17, and the same for the 4.5 plus 1.1, you'll get about 5.6, multiplied by -1 is -5.6. So let me just show you that in the circuit. So I'm going to attach my positive supply and 0 volts and -12 volts down here to this rail. And as you guys can see, I'll put the probe to the output of the 555 timer, and we're getting about 4.23 volts peak, and then 0.17 volts as it's low, and that's before it gets hooked up to the sum amplifier. And the voltage that we're gonna offset it by is about 1.1 volts. So now on the output, so if we take, what was this voltage before? About 4.2 volts. So over here you're gonna get about 5.3 volts, and the reason for that is 4.2 plus 1.1 gives you about 5.3, and that's exactly what we get at the peak, about 5.3 volts. And now since we have to multiply it by -1, so you get -5.3. And then if you take the bottom, it would go to, for some reason it goes to 1.27, and that makes sense. So if you took that 0.01, sorry, it was 0.17 volts, we'll look back at the output of this. You see it goes to about 0.17 as it's low. It's not exactly 0 volts. So if you take 0.17, oops, wrong pin, I had this. Okay, so if you take 1.17 and add that to 1.1, that gives you 1.27, and that's why it went to about 1.24 or 1.27 volts. So yeah, that's pretty much how this circuit works. It's a pretty nifty circuit for adding an offset to a AC signal or making a digital to analog converter, and those are the two things that I mentioned in the last video. So thank you guys for watching, and stay tuned. And I think that this is about voltage summing amplifiers.